and welcome to the Redis Enterprise Virtual Workshop, Building Performant Applications with Redis Enterprise. We appreciate your time today and look forward to a great discussion. Please use the Q&A tab to submit questions or type them into the chat. We also have a few polling questions to understand where each of you is on your Redis journey. We will send out a recording of today's session together with additional resources next week. And now I would like to introduce today's speakers. Al Cole, our Vice President of Professional Services at Redis, and Tom Solon, our Professional Services Training Engineer. And I'm going to launch our first poll question, and that is, what is your experience level with Redis? Some of you maybe have not used Redis before. Others of you might be just starting out on your Redis journey. And others of you might be intermediate or even advanced users. And we will send out a recording of today's session next week to everyone. And it looks like the majority, we have about half of you who are beginning on your Redis journey, which is excellent. About 20% of you who haven't used Redis before. And then we have the remainder who are intermediate and advanced users. So thank you for responding to that poll question. That just allows our presenters to understand where everyone is on his or her Redis journey. And poll question 2, which caching solution or solutions are you currently using in your organization? And you might be using several. You might be using Redis Enterprise or Redis Open Source, perhaps an other caching solution, maybe an Azure Cache for Redis or Google Cloud Memory Store or Amazon Elastic Cache. So feel free to share all the different caching solutions that you're using across your organization. And we will send out a recording of today's session next week, together with additional resources from the workshop. So I will go ahead and end that poll question. Thank you all for your responses. And our third poll question is, which search solution or solutions are you currently using? Some of you might be using Redis Search. Others of you might be using Lucene or Solr, perhaps Elasticsearch or another search solution, or perhaps you are not using a search solution. This just gives us a sense of which search solutions you are leveraging across your organization. So thank you so much. This is very helpful to our presenters to give them a sense of the different solutions that you're using for caching in search for today's workshop. I will go ahead and end that question. And our fourth poll question is, we will be sending out resources for on-demand workshops, but definitely if these are of particular interest, we will share these with you in our resources together with a recording of today's session. So if any of those on-demand workshops are of particular interest, we will include links to all of these next week together with the recording of today's session. And then we will have in-person workshops on these topics as well. So that will just give us a sense of who is interested across which topics. And we'll give everyone just a moment to respond, and then I will hand things off to Tom for today's presentation session. So Tom, over to you for our workshop. Thank you everyone for your participation.
All right, and thank you, Janelle. Welcome to Redis Enterprise Virtual Workshop, Developing Performant Apps with Redis. Well, the way we're going to present this today, first I'll talk briefly about basic Redis Enterprise capabilities, because a lot of you said that you're either very new to Redis or no experience at all, just completely starting out. Then I'll get into programming with a Redis database. We'll talk about the data structures and transactions, and then we'll dig deeper into specifically JSON and search. Along the way, I'll give you a few brief demos just from a command line type of perspective, just putting commands in as an illustration of developing. And then at the end, Al's got this really cool demo, App Studio, which looks at it. He's also built in a front end, so it looks a lot sharper, and it, more importantly, gives you kind of a feel for how these developing things can be put together to make a cool app. Then we'll take some time for general Q&A. So, capabilities overview. One of the first things you have to realize is there's Redis, and then there's Redis, and then there's Redis. And sometimes people get confused. So Redis open source software, Redis OSS, is the database, and it is open source. Redis Enterprise is the enterprise package that actually goes around that database. So we're using the Redis open source database. The enterprise part of it is the management of it. And I'll give you some slides to be more clear about that coming up. And then there's also Redis, the company. All right, so Redis, the company, produces Redis Enterprise, provides database as a service, and is the biggest contributor, of course, to the open source project. So some terms. When we talk about a Redis instance or a Redis shard, we're actually talking about the same thing. Sometimes it's in different contexts, but it's always the same thing. A standalone open source Redis process is known as an instance. And that instance allows you to divide your data. And when it's part of a cluster database like that, that's when we call it a shard. So these shards can be distributed again across one or more nodes, and that gives you the ability to divide your key values among the shards and scale your data. So like I said, the Redis instance is a single-threaded open source database, commonly referred to as a shard, and it will either be a master shard or the original copy, the live copy of the data, or a replica shard, a backup copy of the data. And that's how one of the simplest ways we provide high availability. So the Redis Enterprise database itself is just a logical entity that manages your entire database across multiple Redis instances. All right, this is the sharding happens at this level. Redis Enterprise nodes then are the physical or virtual machines or containers, that's becoming a lot more popular, on which the processes are running. And each node is running every process and has all of the services and software needed to manage database or databases that are in the cluster, which brings us to our final point. That's the collection of the nodes that allows you to pool system resources across nodes. It supports multi-tenant databases. In other words, you can have multiple databases, and here I mean literally separate databases, not just like the DB0, DB1, DB2 namespace separation you get with open source. With Enterprise, you actually can have separate databases with not only segregated namespaces, but separate logins and security requirements and so on. And so it looks more or less like this. You've got two layers. The enterprise layer is the part we provide, that packaging, that automobile, if you will, that surrounds the engine of the database. And so in there, we've got three main components: the proxy, the data access proxy, the cluster manager itself, and the REST API. And then the open source layer is your actual data shards, along with whatever integrated modules you have. So then your cluster would look something like this. You've got a node, and you get to the point where that just one node can't handle it. It's as simple as expanding horizontally, adding another node and another, and however many you need. And so the benefits here of this shared nothing architecture, where every node has everything it needs to do its job, gives you this multi-tenant cluster availability I talked about, capability of running literally hundreds of shards on a single node while keeping them isolated and protected from failure. It simplifies the rebalancing of cluster resources, maximizes your infrastructure utilization, and improves the your utilization of resources. So now let's take a look at these three primary components: the data management controller proxy, the cluster manager, and the RESTful API, starting with that proxy. All right, this is a pretty big enterprise value add-on. It gives you persistent connections with each database shard between the proxy and the shards, so that your code only needs to connect to the proxy. And the proxy takes care of routing the request to the appropriate nodes, and more specifically, to the appropriate shards, rather than you having to keep track the way it is in open source to each shard that has its, its share of the data, and you need to keep track of which data is in which shard. And of course, the proxy itself is multi-threaded, so we can handle multiple requests simultaneously. The open source, each shard, each instance is still single-threaded, like you would expect, super fast, but the proxy is multi-threaded. So if you have a database that has 100 shards, you can theoretically be processing 100 requests at the same time, one per shard, if the requests happen to be spread out like that. So again, to emphasize, every client only needs to know this one endpoint: the fully qualified domain name and port for the database. The proxy itself can serve multiple database endpoints. That's what gives you that multi-tenancy. So each database will have its own port. The proxy also provides ad hoc pipelining, meaning that if you have several requests coming in from multiple clients and they all go to the same shard, the proxy will gather them up, if you will collect them and send them all at once across the internal network to that shard, and the responses will come back as all as once. Since the requests themselves are taking milliseconds, probably sub-milliseconds, this benefit is now you only pay the price of that network hop once. And so your end users are seeing the benefit of that super fast database. Another enterprise-only feature is the ability to have copies or replicas of the entire database. So with open source, those of you who have used it, you're of course familiar with, and anybody who's used enterprise, you're definitely familiar with the idea of a replica shard, where the shard is a copy of the data for one particular shard. What I'm talking about here is you can actually have an entire separate copy of the database itself. All right, so you could choose to have an active-passive situation, where the passive side is just a standby, or is being used temporarily for data migration, or perhaps database restructuring. The advantage is it's live and active. So the active side is still accepting reads and writes, and those reads and writes are getting propagated to the passive side as it happens. So if you're using it for data migration, for example, when you're ready to make this side the live side, it's just a matter of flicking the proverbial switch to make this one the live one, and it's already up to date because even while you were creating it, it was getting updated. But wait, there's more. You can also have active read replica. This is actually a special use case of the active-active. And the idea here is you configure one side to accept reads. So all of the writes are going to the active side, and the reads are being distributed across both the active and the read replica side. So that allows you to control where the writes are coming in, but then spread out the reads over your system, over more machines, more zones, or maybe even around the world. And then finally, active-active, where you actually have two full active copies of the database, both sides, or I should say all sides, because you can actually have up to 9 participating clusters. And you can get even more, but it requires some additional intervention with support. You'd have to fill out a support ticket. But even without a support ticket, you can have 9 clusters, each of them accepting both reads and writes, and the enterprise software taking care of keeping the whole network up to date with the writes. All right. The next is the cluster control, the cluster manager. The master replica cluster architecture ensures that exactly one node is the master node, and that master node is the leader of the cluster that is in control of all of the overall cluster operations, the health, shard provisioning, coordination of cluster activity, statistics, alerts, backups, and so on and so on and so on. All right. Now, if the master node goes down because stuff happens, right? Murphy's Law, a replica node can automatically and transparently be promoted to a new master node so that you're still up and running. And this will be transparent to your client code. They're not even going to need to know that anything happened. And this provides additional high availability, potentially up to, depending on your configuration, 5 nines service level agreement. So let's talk a little bit more about those nodes. There are actually 2 types of nodes, a data node and a quorum node. The data node does exactly what it sounds like. Basically the same kind of division that I showed you in our original little node diagram, where you've got the open source data shards, and we put the proxy up here. Even though the proxy is part of enterprise, it is obviously data path, right? So we're showing that up here in the red when we divide it into to job responsibilities instead of areas of where to come from. So we've got our usual data going on, and then the cluster management and the secure GUI, REST API, CLI is going on in the control plane. So data plane, control plane. The other type is a quorum node. And with the quorum node, probably you're pretty bright, you immediately recognize that there's no big red box up here with shards on it. The only thing it has is the control plane. So both types of nodes, though, can be the master of the cluster. Both count and participate in the cluster quorum. In other words, the minimum number of pieces that need to be present to do business. The data node is the default situation. If you want a quorum-only node, you need to explicitly designate it, either in the CLI or through the REST API. Why would you want one? Well, the name kind of gives you a hint on that. It's for maintaining quorum. In fact, the technical name for it in the CLI is a quorum-only node. And here's the difference, big difference between Redis open source and Redis Enterprise. With open source, quorum is by shard. So you actually need to maintain multiple copies of your database. Then let's say you have a network split. Again, node 1 hasn't gone down. It just can't communicate with the other nodes. Basically, the system recognizes, oh, we can't communicate with the master shard anymore, but we have 2 out of 3 copies. We're the majority. We have quorum. We're going to keep processing, and the master shard becomes a replica shard, and one of these 2 will get promoted to master. Okay, it works, but it's a little on the expensive side. With Redis Enterprise, we use nodes for quorum instead. So you only need to maintain 1 copy, 1 replica of your data. Then let's say hypothetically the same situation where the node with the master shard gets separated from the rest of the cluster. Here, the cluster manager is going to say, I have 2 out of 3 nodes. I still have a quorum. I have the majority. Now, the benefit of this is you don't have to maintain the additional data copy. On the screen, we're showing an example, a really simple 120 something gigabyte node. You would need an AWS R4 4 extra large. And I recently went online at AWS, and the on-demand price for that is $1.06 an hour, US dollars. By contrast, let's say you size out your database and you determine that I really only need 2 nodes to handle all my data. You can establish quorum with this quorum only node. And for that, you can get away with an M4 large, merely 15 gigabytes. And that cost $0.10 an hour, 1/10 of a USD. All right, obviously cheaper by more than an order of magnitude. And that's the idea. That's the point we're getting at. So now let's talk about some of the things that could happen and how your Redis Enterprise cluster is going to handle them. We're not going to look at the whole wide variety, just give you a few glimpses, a few of the possible scenarios. And of course, the simplest is a shard failure, a single process failure. So if you've got a database with high availability turned on, we're only showing 1 shard here for the database. That could either be representing one of the shards or a single sharded database. Maybe that's all that's needed for this particular one. So you have a master shard and a replica shard. If the master shard process goes down, or even if the entire node goes down, then the cluster manager sees that happening and automatically promotes the old replica shard to a new master shard, and you're open for business again. Now, if you're really interested in high availability, there's a feature with called replica high availability. So initially, yeah, you've got the master shard doing business, but now it doesn't have a backup. So with replica high availability, once the grace period expires, the cluster manager will say, oh, I need a new replica in order to maintain high availability. And so it will create one. Eventually, node 1 is back up and running. If you had replica high availability turned on and the grace period expired, then okay, great. Welcome back to the cluster. You're certainly welcome to participate, but right at the moment, we don't need you to do anything for us. We've got a working condition. Now, an additional layer of protection is to have persistence turned on. All right, so in the previous, the replica shards, I hope you realize, are still in memory. You know, if both the master shard and the replica shard die, let's say, for example, because your entire server rack or server system or availability zone went down, you don't have the data anymore. But Redis can persist it. Again, it's a setting. You choose when that's appropriate for your particular database and only incur the cost when you need it. So the way it works by default is the persistence will actually happen as a process off of the replica shard. And that allows us to keep on very quickly handling more requests as they come in, because it frees up the master shard. So a request comes in, if it's a write request, it gets persisted to the replica and then persisted to disk. Well, technically copied to the replica, that's not persistence yet. Then hypothetically, if you lose both of these, you still have your data on disk. If you want, as the admin, you could, or your admin could do this for you. If you're the developer, spin up a new copy of the database on the surviving node, one of the surviving nodes, and install the database, and the system will recognize, oh, that's supposed to have data, and it will automatically repopulate. If those other nodes are down just temporarily and they come back, you know, I'm not dead yet. All right, cool. The system comes back and the cluster manager recognizes, oh, okay, yep, I have a database here. It's supposed to have data in it, and it will go to your persistent source and repopulate the data. And while that's going on, new writes will get persisted again off of the replica shard. Let's look at an even bigger failure, because I mean, you know, anything that can go wrong will, and in the most disastrous way possible. So let's say you've got a really big, really important database. And so you want the best high availability you can get. Rack zone awareness is what's going to help you with that. And that's a feature that you actually specify which server rack or which availability zone the nodes reside in. And then your cluster manager always puts the replica shard on a different rack or in a different zone. So let's say hypothetically you've got this 4-shard database. So one database is shown here. You might have more, but this is showing one of them that has 4 shards. Each one has its own replica shard, and those replica shards are always in a different server rack. In this case, let's say that the master is node 5. Now, again, there's no such thing as a master rack or master zone. This is a master node. So node 5 is what we're talking about as the master here. So let's figure worst case scenario, what could happen? Well, I suppose the entire rack with the master node on it goes down. All right, what's going to happen? Well, the first thing that happens is the cluster manager recognizes that it doesn't have a master node. And so a new node is elected by the other node to be master of the cluster. Let's say hypothetically node 9. Now that we have a new leader, the leader can make everything else happen. Make it so. All right. And so replica for the shard that was lost gets promoted to master. And then any master shard that does not still have an active replica, its replica will also get copied on a different server rack so that you don't lose any of your data. Now, if this node or either A or C also goes down, your database will be down, but you won't lose your data. It'll be down because you don't have quorum. 1 out of 3 is not quorum. but you won't have lost your data because whichever one survives will have either a master shard or a replica shard. All your data is saved. Redis Enterprise provides a few additional improvements over the append-only file feature that is in open source. Now, both can do your choice of every write, which is going to basically flush to disk after every single write operation, or every second. If you can afford to lose up to 1 second's worth of writes, you would choose this more relaxed setting, and that accumulates writes over the course of a second. And then once per second, ships them all off to disk. Again, as I showed you on the previous slide, the default enterprise way is to leverage the replica shards, kind of like a disk IO thread. We also have an optimized append-only file rewrite frequency, and we optimize the chunk size. Next thing, the third final piece, the large puzzle version, is the REST API. All right, so here we're talking specifically about cluster node manager HTTP, and that's it. Cluster manager server is the GUI. So the HTTP here allows you to automate pretty much anything via scripts. You can write a script that'll do your configuration management, orchestrations, visualization dashboards, whatever you need is available. It's also the backbone of the admin console and the RL admin command line utility. It allows you as or your admin to initiate processes like database creation, failovers, cluster configurations, updates, fetching various statistics, and so on, entirely from the REST API, or if you want, the CLI or the GUI. And that's what makes possible this sort of thing. So one of the things built in is the GUI and all sorts of metrics, including some tools for, expanding them up, getting side-by-side comparisons, and so on. Additionally, Redis Enterprise beefs up the built-in Redis Enterprise, Redis open source ACLs and RBAC. All right, so we allow you to define roles, so the access is applied to roles instead of to users, and that way you can reuse them and apply the roles to the users instead of having to give specific access control to each user. We use the same syntax as the open source, but again, beef it up a little bit. Also, Enterprise gives you the opportunity to link your database to your lightweight directory access protocol server, so that you could have access provided by LDAP instead of individually logging into the database or logging into Redis, in other words. So in summary, we've got this shared nothing, symmetric master replica architecture, segregating the cluster management from the database to improve the database, that is to say, client code perspective performance. The databases can scale out on demand and be highly available and be persisted if that is what you need. The various processes on the nodes and in the cluster can be monitored individually and traced for health checks. And then also your admins can make whatever changes necessary through their choice of the management UI, the REST API, or the CLI. All right, enough of the background information, Tom. Let's get on to what we're supposed to be talking about. Yep, time to do that. Let's talk about programming with the Redis database. So Redis data structures use unique layouts and operations for storing and accessing data efficiently, often in milliseconds or sub-milliseconds, right? Even for enormous data sets. This is the performance you're accustomed to. Now, people new to Redis know, okay, it's a NoSQL key value pair. Yeah, I know what to do with that. What you might not have realized is a string is not the only data structure that you can store. All right, we've got strings, sure, but also lists, sets, sorted sets, hashes, pub/sub, bitmaps, geospatial, and more. And that allows you to actually store the things you're working with in your code, you can store. If you have a Python dictionary, you don't have to convert that to a database row. You can store a hash. Or for that matter, if you have a Java hash, if you're writing in Java and you have a hash, you need to store it, you store it as a hash. If you have a set that you need to store, you store it, surprise, surprise, as a set, making your job as the developer that much easier. So here's an example, actually a couple of examples. One of them is a simple hash. So your hashes, again, they're like a Java hash or a Java map, and like a Python dictionary, similar ideas in every programming language, just about, where you've got these field value pairs. So in this example, let's say it's, patient information. So patient 1 is John Rambo, and he's 55 years old. We want to increment that. Yeah, I know age isn't usually stored as an integer. You store the birth date and calculate the age, but bear with me because I wanted to talk about hinkerby, where you can actually do an operation on an individual field. Hinkerby patient 1 age incremented by 1. And that goes up, and we don't need to draw the entire hash into our code, do something with it, and put it back. We just say, hey, increment the age. The other cool thing is, like a map, it isn't schema. It doesn't have a schema. It is schemaless. It's not like a database table where you need to add another column to add another field value pair. You just, hey, age set, patient 1, weight 99.2. Now, obviously, John Rambo was never a 99-pound weakling. I don't think he was weighed 99 pounds even when he was in first grade. All right, I think he was, born big and nasty, but whatever. The point is you can set a value, a field and a value at once, and it doesn't matter that it didn't exist before. Similar concept now with sets. You can, of course, do the sorts of things that sets do, like an intersection or a union, and we have separate commands for that. And those data structures are what allow you to use Redis as the traditional cache, sure, but also as a database or message broker, a session store, queues, stacks, time series data, geospatial data, and even search engine querying, secondary indexing, which brings us to the next concept, extensibility. So the modules that can be added, either the enterprise modules that we provide or ones that you develop yourself or find in the community, allows you to extend the Redis database, basically to do whatever it is that you need it to do, and turns Redis into a multi-model database. We have an enterprise product called Redis Stack, which ships with our search capabilities, secondary indexing, query engine, full text search on hashes and JSONs, polygon search capabilities, probabilistic data structures, like cuckoo filters and Bloom filters, document database capabilities in JSON, time series, vector similarity search. We've got a separate webinar coming up specifically about that. Provides the Redis Insight GUI, object mapper, client libraries, and a lot more. We'll dig into two of these specifically coming up later, the JSON and the search. So now let's talk about some typical use cases and how you as a developer might take advantage of Redis to get it done. This first one, for you, it may be the primary use case, maybe of what all you knew that Redis did when you first heard about it. The original reason that Salvatore Sanfilippo wrote the open source project in the first place, to have a fast cache. So if you need to cache your web pages, because rebuilding them on every request stinks, you could use strings. And with strings, you can do a set to set a value or get to retrieve values. And it could look something like this. So set user:1. So it could even be, user by user or session by session caching. With, obviously, you wouldn't cache empty HTML tags. This represents the entire HTML document that is the web page. You can get it. You can set an expiration for it. You could also even set an expiration as an argument to the original set. And when user 1 logs out, you no longer need it, so you can do a delete on it. Now down here, this is showing you the same commands in the Redis library, which is one of the libraries that for Java, for Redis. And yes, this is pronounced Redis. In case you were wondering, you don't get a lightsaber with this. It's Redis. But what I wanted to point out here is that most of the client libraries, and a lot of them are community sourced, they try within the bounds of the particular language to make their commands the same as the Redis commands. And that's what makes it really easy to transfer your Redis experience into those libraries. Excuse me. Or let's say you need to store session data, which is typically a bunch of fields and their values. And of course, maintaining session state needs to be fast, low latency. Hashes work really well for that. So would JSON, but hashes are even faster. And then there are separate commands for that. So set allowed you to set a string. Hset, as in hash set, allows you to save field value pairs into a hash. Hget allows you to get one of those values. Hmget, as in hmultiget, allows you to retrieve multiple values. Hincreby, hash increment by, allows you to increment integer fields. Hdel, hash del, allows you to delete an individual field. You can still use a del, but that is actually going to remove the entire hash. So, for example, you might have a user session. User 8754 named Dave at this IP address comes to your website and you mark, okay, he's hit our website once. You need to get his username and IP, hmget user session 1, user ID name. Would get the user ID and name. IP hits would get the IP and hits, right? Dave comes back to your homepage or comes back to The site, while the session is still live, hinkerby user:1 hits 1 will increment hits to 2. If you want to, then you decide, oh, I need to keep track of what page he's last been on. I can do an hset user:1 last page home, and it will add it to the hash. And I can get that. And if later I don't need it anymore for this particular session, I can hdel it. Dave logs off. Dave's not here. Then you can do a del on the entire user session 1. And then there's Redis as a queue. Let's say you have worker processes, or maybe even physical human workers pulling support tickets. Whatever, a queue can help you do that. Lists operate very well as queues. L-push in this case doesn't mean list push, it means left push. R push is right push, and of course there's an L pop and an R pop. There's also an L move, which allows you to atomically pop an item off of one list and push it onto another. And so that might look like this. You've got Q1, which has these various jobs that come in. So first you queue up the orange job, the green job, the blue job. Let's say hypothetically you have a high priority red job. You might want to put that at the tail of the list. In other words, next in line to be operated on. If that's the case, you do an R push instead of an L push. Then as you process them, you can use an L move. So move from Q1 to Q2, from the right of Q1 to the left of Q2 will atomically move the red job in this example from Q1 to Q2. Let's say this is the wait queue, the in-process queue, whatever, or the processing queue to the completed queue. And then, of course, list, if you only push from one direction, you've got an append-only list. If you push and pop from the same end, you have a stack. You could also use sets, for example, for a recommendation index, recommendation engine. You want this to actually be user data. Let's say maybe they're in an e-com site, it's tags, that users put on the recommendations, whether it's useful or not, or in a blog post. This is political, that's cultural. S-add, again, this is not a depressed addition. This is not a sad item. This is a set add, to add a member to a set. S is members, checks to see if this item is a member. S members gets you all the members of the set. S inter gets you an intersection. S union gets you a union. You got the idea. And so that might look something like this, where you've got users, maybe this is a blog post or something like that, that are tagging articles as fashionable or comfort or colorful, or maybe these are product descriptions, product endorsements. You want to find out everything that the users say are colorful, you do an S members tag colorful. And you can find out that that includes Article 3, Article 2, and Article 9 in the blog post example, or Product 3, Product 2, Product 9 in an e-commerce recommendations example. You need an intersection of what is fashionable, comfortable, and colorful, S inter of those three sets. And we'll tell you that Article 3 is about those topics, or Product 3 is about, meets those criteria, whatever. So the additional set commands, S inter gets you an intersection. So if these are your sets, S inter will show that Russia is in both. S union will get you the union. Now, the result of both the S-inter and the S-union is itself a set. And that's why the union lists Russia only once, because by definition, a set is a unique collection of items, or a collection of unique items, I guess I should say. Another very common use case for Redis, leaderboard. So you've got a gazillion users playing a game and collecting points, and you want to display a real-time leaderboard. You know, who's the nearest competition? Who's the next one I need to overtake? Obviously, disk-based database is way too slow. A Redis sorted set, a special use case for sets where each member also has a score. Now, S was already taken for sets, so instead we're doing Z add, Z range. Well, unless you're in Canada or the UK or Australia or India, pretty much anywhere else in the world other than the US, where you'd call it a Z. So whether you do a Z add or a Z add, that adds an item with its score to the sorted set. To get a range of values, Z range or Z range. To get the rank for a particular member, Z rank. So let's say, for example, you've got a Redis database and it has a bunch of different games going on. In game one, you have, among other things, these 4 users. So user 1, 2, 3, and 4, and here are their initial scores. User 3 kills an orc, gets 10,000 points. Yeah, you probably think an orc isn't worth 10,000, but it depends on your universe, your fiction. And so all you need to do is a Z inker by for game 1, 10,000 points to user 3. Not only does that add that 10,000 points to player 3's score, but automatically resorts the leaderboard, putting user 3 on top. Then if you need to find out, well, who's the top player, Z rev range, reverse range, because we want descending, not ascending, for game 1, the 0th through 0th user. And it tells us that's user 3. Or let's say you want to know the first 2, the top 2, and you want to know their scores too. Z rev range still, but now the 0th through the 1th player with scores. Come on. There we go. I can operate a slide deck. I've been doing it for a while. All right, cool. You can also use Redis as a geolocator. Give me all the pharmacies within 2 kilometers of where I am right now. Or where's my ride share? Or where's my delivery truck? So a geo set, which is actually a special use case of the sorted set. Here, we decided to give up on the whole 1-letter thing, and we actually use geo. So geo add adds a location, a member and location, I should say, I guess, to the geo set. Geodist will get you distance between 2 members. Georadius or geosearch allows you to search for members within a particular radius or within a box. And so that might look like this. Let's say you start with your database has all the pharmacies in London. There are more than 3. This is just showing you a subset. And then your customer is on their smart device and they say, what are the pharmacies within 600 meters of where I am now? So you as a developer translate that into geo-search terms. So from the pharmacy sorted set, from the longitude, latitude of the current user, the current requester, I want to know by radius of 600 meters, what do we got in the set? And by the way, I want to know them with distance, with coordinates, and if there's more than one, give it to me in ascending order. Now, it turns out that there's only one pharmacy within 600 meters of these coordinates, and it's the Charles Harry Pharmacy, approximately 512 meters away. And here's its lawn lat. And so that then you toss into the mapping app and drop a pin on the position so your user can find it. There's also a pub sub feature in Redis, which allows you to broadcast messages to subscribed listeners. Here, the commands are just blatant: publish and subscribe. So with pub sub, you can have one or more publishers publish messages to a channel where one or more, or maybe even many subscribers, rather than subscribing to the publisher, they subscribe to the channel. And so the publishers and subscribers don't need to have any knowledge of each other. And of course, the reverse is also possible. You can have a publisher publishing out to multiple channels, and or a subscriber subscribing to multiple channels. Now, one of the downsides of PubSub, it's really fast, but it's also fire and forget. It's like it sends out, hey, anybody that's interested, here's my message. And if you're not listening, it's kind of like a radio broadcast, if you will. If you're not listening, you don't get the message, and that message isn't persisted anywhere. If what you need is guaranteed delivery, then maybe what you want is Stream. So Stream has guaranteed delivery. Now, in this example, we're using it as a time series. You could also use it to send messages where then those messages with your guaranteed delivery can be processed individually by the consumers. So once again, S was already taken, so we're using xadd to add a message, xrange to retrieve a message or messages within a particular range. So for example, let's say you've got a HVAC, an environmental control system for a building, and you're keeping track of these various sensors. So there's a sensor in the hall with Colonel Mustard, and there's a sensor in the ballroom with Miss Scarlet, and there's a sensor in the conservatory with Professor Plum, and so on down the list. Here we're looking at just the hallway. All right, so xadd sensor hall asterisk temp 22 air quality index 33 the asterisk says to the server, use the server side timestamp. If you wanted to use the client side timestamp, you could do that. You would simply provide the value here from the client side. But to keep things consistent, let's say hypothetically, this HVAC system wants to always use the server timestamp. So we just enter them with an asterisk. And these things are keeping track as it goes along. And so you can get an X range for sensor hall from this time, and then a plus means anything greater. Count 2 says only give me 2 of them. All right, and so in this example, you might end up with these 2 values returned. So in streams, we don't call them publishers and subscribers. We call them producers and consumers, but the same idea. Now, in this case, if we're looking at locations and temperatures, maybe it's because the consumer is going to graph them, or possibly the consumer is going to aggregate them. The point is, it doesn't matter what the consumer is going to do with them. We can guarantee delivery so that the consumer knows it has all of the data. Now, there's actually a little bit more complicated if you have a large database. How large? Large enough that you need to shard it. All right, so we talked before about having multiple shards to the database. Well, why would you want to do that? Because you got a lot of data. Through years of experience, we've discovered that a shard can handle an open source process, a single shard can handle about 25 gigabytes of data. The exact amount varies on, your exact use case, but it's around 25 gig. And it can handle about 25,000 operations per second. So if you either have more data than that or need to process more requests than that, you need to separate your database, and you do it by sharding. So for example, let's say you decide you need 4 shards. Each of those shards will have 1/4 of the field value pairs. And you'll get to that with a hashing algorithm. That's how the system will decide which data goes to which shard. And then here's just a separate graphic to show that. We actually hash, the hashing algorithm uses the key. So in this example, user ID might go to slot 0, and event user ID hypothetically goes to shard 8, and so on down the line. While we're talking about hashing the key, let's briefly take a side trip into the importance of the key value pairs themselves. All right, so you want your keys to be descriptive enough. All right, this isn't a relational database. That doesn't mean we can't express relationships. So, for example, Latin is a language course, or 11 is a pending task, and 13 is a completed task. So if you construct your keys properly, it can be pretty easy to find the actual data you need. You need to know about a particular task. All you need to know is whether it's pending or completed. Or you need to find out what tasks are completed. You can scan for task completed, etc. The issue, though, comes with multi-key commands. Anytime, and this is true for all Redis databases, open source or enterprise, anytime that a command works on multiple keys in a sharded database, those keys need to be in the same shard, because of the way the database works. If you send a rename to a shard, it has no way of saving that renamed field, that renamed key, to a different shard. It's got to be in itself, to use one example. So then what are you as a developer going to do? Well, one thing is, if you're already using Redis Enterprise, a few of the multi-key commands are supported. Del, multi-set, multi-get, for example, and there are a few others, but not many. In which case, in Redis Enterprise, we're actually going to use the proxy. If you have a multi-set, an mset, we're going to use the proxy to divvy those out so that they can go to the right shards. For everything else, what you'd want to do is use hashtags. Now here, by hashtag, I don't mean, hashtag wish you were here or hashtag follow me. We mean a tag that constrains the hashing algorithm. So anytime the server sees curly braces, and again, they need to be curly braces, a Mo brace or a Larry brace won't do. If it sees an opening curly brace followed by a closing curly brace, that says do the hashing calculation on only what is between these braces. So for example, if I have hashtags around user ID, then user : hashtag user ID, events : hashtag user ID, and message : hashtag user ID will all hash to the same slot because we have a constant hashing algorithm. It's a CRC16 modulo 16K, and the same value as the starting point is going to come to the same mathematical answer. So in a more specific example, instead of generically saying user ID, let's say the user ID is 555. And we want to do, let's say, a transaction. So multi and exec, not going to talk a lot about this in this workshop. It's a little too short to get that in, but this is a way of turning these three requests into a single transaction. But if you do that, they have to be in the same shard. There are additional reasons why you might want these keys in the same shard. For example, you want to do other multi-key operations on them later on. So I can have an X add, that would be for a stream, events : user : hashtag 555. And I'm adding a type alert sensor 4. And maybe because there's a sensor 4 alert, I want to also set messages : user : hashtag 555 and say check alert sensor 4. And maybe I also want to update the user's hash. In other words, the collection of user data, user : hashtag 555, status attention needed. Because they all are hashtag 555, they're all going to calculate to the same hash slot. Probably not 2, 3, 4, 5. There's a 1 out of 16K chance it'll be that one, but whatever it is, it'll be the same. So the example I gave you earlier with sets and a set intersection, if you have a single sharded database, that'll work just fine. If you have a multi-sharded database, then you need to do a little bit of additional work. And here, for example, is how we could make that happen. Sadd hashtag tag : hashtag. No, there's not an echo in here. Fashionable. Hashtag tag : hashtag comfortable or comfort or whatever. And so on. Then when you do the intersection, because of the hashtags, all of these will be in the same hash slot. So let me demonstrate what specifically I mean by that. So this is just a Redis Insight. It's a cool tool that's available, by the way. It ships with Redis Stack, but you can also download this separately from redis.com. Here I've got currently some JSON for a later demo. We'll come back and we'll see that now. We'll see that later, excuse me. For now, I just want to do this. I just want to use this workbench. It's a quick, easy way of getting a CLI, getting a command line. So for example, if I had, let's say, a set of primary colors, lab sets color primary, red, blue, green. Go ahead and execute that. And I have sets, let's say, well, actually, first, let me do an S members to show you that that's there. And then let's say I also do, whoops, I keep forgetting though, I have this set up to do, you got to do the arrow. That way I can put multiple commands in. Same kind of thing, sadd for sets color secondary. And so that would be cyan, magenta, and yellow. Now, if I want to do a union on that, what's going to happen? Well, I'll give you a hint. This is a sharded database. So now when I run it, I get cross slot keys problem. Same thing happens with something as simple as multi-exec. If, for example, I wanted to do multi, I don't know, set hello world. Oops, come on. And then set greeting planet. Cross slot violation, because hello and greeting aren't going to hash to the same slot. So let me discard this transaction and show you an example of doing the sets. So if instead of doing the previous where no hashtags, if I do sets hashtag colors ink and put in the secondary colors and black. If you've ever wondered why it's CMYK, it's the secondary colors, and black is the other ink color that is typically used. And B is already taken for blue, so it's K for black. Anyway, yeah, TMI. And then I could do colors lighting, which is your RBG. Now, if I want to do a union of those, I can, because they're in the same set. I could even do, more. I could add, do a set add for colors of the rainbow, and then do an intersection between rainbow and lighting, or whatever I wanted to do. It's going to work specifically because I use the hashtags. Now let's take a look at two of the components of Redis Stack. First thing I'm going to look at is JSON. The second is search. So JSON allows you to implement the ECMA 404 standard. And despite the number, it's easy to find on the internet, including JSON path-like syntax for selecting elements inside your JSON document. You could do it without JSON, but there are downsides, whether you're doing it as a serialized string or deserializing, decomposing it, if you will, into hashes. But with JSON, you can atomically perform operations, sets and gets and inker bys and appends and array appends and so on. There's no memory bandwidth of deserializing and reserializing, and you can do nested. So JSON support, the JSON standard, ECMA 404 supports having a value that is itself a JSON. And so you can do that now with this. With hashes, it's just field value, and that value has to be a string or number. So let's say you've got this type of object where we've got, a plain string. We have a number. In this case, we're saying category is an object that has two values, or two field value pairs, I should say, ID and name. And then tags, descriptions about this product, which is an array of strings. I can add the initial document like this. So JSON.set product1, the path, and then the JSON, and optionally provide the entire thing that I want. So JSON set, like with strings and hashes, set is the same command whether you're adding a whole new document or simply setting a new value for an existing field, or for that matter, inserting a new field value pair. So JSON get on the key name will get the entire JSON document, or JSON get key name and then a path to an individual field will get you the value for that individual field. If you need a subfield, like for example, the name of the category, just specify the path, root.category.name. If you want to get something out of an array, you know the syntax for that. Root dot the name of the array, and then square braces around which item you want in it. And the full JSON syntax is supported. So you could even use wildcards, for example, to find the specific element if you don't know its index. To append to an array, it's JSON.rAppend, as in array append, or JSON.numIncreBy to increment a number. And here, numIncreBy accepts floats. And we'll add, so you can add fractional data. It doesn't have to be increBy, which would only support integers. JSON obj keys will return you all of the keys, but only the keys for any JSON object. In this example, just the category object. So now in the next demo I'm going to do, this is the way this is what I'm going to be doing. We're going to be looking at a hypothetical real estate app where we have properties that have an address, which is an object that has street, city, zip, state as its fields and values, and then a bunch of other numeric, number of bedrooms, number of bathrooms, square feet, another string, a date field, a numeric field for the price, and a geo for the location. And once again, here is an example of what I'm doing. And this delay, by the way, is my home internet. When I practice this, not trying to broadcast it over Zoom, it shows up instantly. So let me just show you here, for example, the address is the object. Here's our location as lawn lat. If I need to add a new property, let's say hypothetically property 42 with this name, address, and so on. Okay, it's done it. I want to know, okay, what type was that for sure? Type is a generic open source command. Type on property :42 tells me that, yes, indeed, this is a Redis Enterprise JSON. If I want to get the whole thing, I can do that. But of course, it's much more efficient to get only the information you actually need. So if all I need is the street address, what I want to do is just get the street address. If all I want to do is get the sale price, then I should just do that. Let's say, hypothetically, that somebody finds out that 001 Cemetery Lane is haunted. And so we want to decrease the price by 10,000. That would be a numIncreBy negative 10,000. I don't know, this time of year, maybe haunting for that kind of address is actually a benefit. And so we want to increBy. We want to add 10,000. Instead of deleting it, all I need to do is get rid of that minus sign. And now the price has incremented by 10,000. Let's talk search. All right, what can it do? Well, we can query numeric ranges, tags, concrete values, aggregations, do aggregations on those values, do a full text search, complex Boolean queries, and not shown here on this slide, but as I already mentioned before, vector similarity search too. That's out of scope for this this demo though, this discussion. So the basic idea is that you create a collection. All right, so you've got a collection of documents which make up the index. Each one has its ID and the fields and their values. Now, not all documents need to have all the same fields. In this ecom example, we have a product that has color and another product that doesn't. That's fine. And you can still index and search on color. That just means this one has no value, a null in essence, as far as the search is concerned. The document doesn't have a schema, the index does, and that defines how things are going to be indexed. These indices are automatically populated based on the database in your based on the data in your database, and they are indexed according to following a specific key name pattern. So, for example, ft_create, that by the way is how you create an index, creating a new index called e-commerce products on hashes, give me the index for every key that starts with product : If I also wanted to index service : prefix 2, product : space service : and then the schema, in this case, just keeping it simple, name, which is text, price, numeric, color, a tag. The same idea, but showing also that you can filter. Now, this filter is not a search filter. It's an index filter. In essence, we're saying, I only want to index the expensive products over 1,000 whatever units. The same thing showing for JSON. The difference is just here in the schema. For JSON, you provide the path to the field that you're indexing. And then an alias. How is it going to be used? These are the field types. This one I do point out that vector is available. But what we're going to be focusing on for the search is the numeric fields, tag fields, text fields, and I'll briefly mention geo. Actually, it's part of my demo, so even though I won't spend a lot of time talking about it, you'll get to see it a bunch. So defining the schema. Here, we're getting a little bit more complicated and showing that, let's say SKU is numeric, but I also want it sortable. Now, you can sort the results of any search, but if you're sorting on a sortable field, that sort value is actually part of the index, and so it's going to go a lot quicker. So don't do that on everything. Only do it, though, on the things that actually need it. Text, let's say that the name is text, but we're not going to be doing any stemming. There's no different tenses in our product names. And I want to weight that as 1.0. That's the maximum value, saying that, if the shopper is looking for a particular word and it hits in the name, that's twice as important, weight 0.5, for the type. Price is numeric, sortable, short description. For short description, we're also adding an optional argument, phonetic. In this case, and then you have to specify the dictionary. So we're using the double metaphone English. We also support DM Spanish, Portuguese, and French. Long description. We're not going to bother doing phonetic searches on that, but it's going to be a weight of 0.5 because, possibly more noise. And so on down the line. Now, stuff happens. You may decide that you need more things. Now you want to index on available stock. Fine, there's a command for that, ft alter, and then set it up. And then this will automatically trigger a reindexing of your documents, which can be avoided if you want by specifying an additional argument, skip initial scan. To add a document to the index, you just add it to the database. So whether you're doing hashes or JSON, the act of adding a document will automatically add it to the index as long as it matches the prefix that you defined in the schema. Every time an indexed field is updated in a document, you also get the benefit of it automatically updating the index. Every time you delete a document, the index updates. All right, so that's the concepts with indexing. Now let's talk about the queries. So to query on a specific field, you just specify at field name : value. So for example, FT search e-commerce products, quote, at name : TV, close quote. If it's a numeric field, you specify the range using square brackets. So at price : within the range 500 to 1,000, which would hypothetically give you this kind of result. So this is saying, I got 12 products that match that. Here's the first one. Here's its value. And then 4 would be the next product. 5 would be its values, and so on. And then here's the syntax. This is in the documentation. I don't intend to read this to you, just to point out, yes, the syntax exists for excluding the beginning and or ending, or opening the upper range, lower range, etc. Now with tags, you have to include the curly brace, not a shemp brace, a curly brace, at field name : for example, curly brace black, curly brace. This is what identifies it as a tag. If these were missing, it would try to find text that says black, but it wouldn't exist because we didn't index this as text. We indexed it as tag. Geospatial queries, it's a numeric, so it's going to be in square braces, but now instead we're providing the longitude, latitude, radius, and the units of the radius, where the exhaustive list are these: M for meter, km for kilometer, mi, mile, ft, feet. If you want a full text search, simply don't specify the field name. So this is going to look for the string TV in any text field. The default delimiter, space, means and. So this search, for example, says, give me the e-commerce products that have color black and are in this price range. This says, give me e-commerce products that have TV in any text field and have 4K in any text field. Doesn't have to be the same field. If you want or, you have to specify it with the pipe or the bar. So this changes the previous example to an or. Color black or price in this range. Or if it's two different options for the same field, it can be done in the value side. So at color : hashtag black or white hashtag. To negate, you simply use the negative sign. So, and the negative sign can go either in front of the field or the value, depending on what makes sense for your particular query. So any product that colors not black, which by the way will include any product that doesn't have a color, because null isn't black. Or any product that has TV in any text field, but does not have smart in any text field. If what you actually wanted was an exact quote, then you need to include that request in double quotes. So for example, double quote bright star, double quote. in which case you either need to escape the inner quotes or use single quotes on the entire query so as to avoid confusing the command line with the double quote. Field weights allow you, as I mentioned before, I explained before, to say this field is more important than the other. Now, that's only for sorting the results. That does not in any way affect whether it's a hit or not. And then the last thing I want to show you before going on to demonstrating this is that with Enterprise, you actually can search across a multi-sharded database, because the proxy will do this scatter and gather to get all of the actual individual indices. So now in the demo, we're going to take that real estate app example to the next step by adding search capabilities. So I'm going to create an index on the JSONs that I already have that you saw before. And here's the schema. And here's where aliasing is going to help out. When I do, for example, address.city as city, that means my FT search then only has to search on city. It's not searching on $address.city. So let me head back over to over here. And the first thing I want to do is create that index, which I have not yet done. If I had, this would actually throw an error. It would say that index already exists. If you want to change an existing one, you need to use FT alter, not FT create. And then let's say I want to search on anything in the real estate products in Sacramento that has exactly 3 bedrooms, exactly 2 bathrooms, and at least 1,000 square feet. And the results I get, again, notice that the search was done in 12.786 milliseconds. It was merely my display here that took a little bit longer than a bit longer than that. One of the things that made it take long is I retrieved the entire JSON document. If instead I specify I'm only interested in the city to verify it's Sacramento, the number of beds, baths, and beyond, I mean the square feet, then that comes back a whole lot quicker. If I want to also do a full text search, find garages, I can do that. And whoop, it's not showing my, there it is. Scroll up, show you my results. Sorry. I also, I wasn't showing the right screen here. Here's the results for the previous search. Here's the results for this search. I can further narrow it down by location. So for example, say, I wanted, or in this example, swimming pool also. My next example is the one where I'm also including the location. So within 5 miles of, let's say this is the coordinates of my favorite park. So I want it within 5 miles of my favorite park. And that would get me now narrowed down to just those within 5 miles. I can also do aggregations, narrowing the search, and so on. And that's enough of my theoretical stuff. I'm going to hand it over to Al to give you a little bit more, a cooler demo with some practical stuff. So let me stop sharing here.
I'm on a different laptop, folks, which is why I wanted to confirm you could hear me. This is just a lab machine that I have, and we're going to run a demo from here. And what I want to show you is really just a fully built application, which is trying to solve for different use case scenarios, but in all cases using Redis as the database under the hood. Before I get started, I just wanted to show you the data behind the applications. So this here in the spreadsheet is just a HR employee record data set. It's mock data, but as you can see, it's got a nice combination of some property information coupled with some job descriptions. So it makes it helpful to work with data sets like this. To the right here, I've got a listing of a series of JSON documents, and they represent an e-commerce site, Best Buy. And I just leveraged their API. This data set might be a year or two old, but it is obviously rich in metadata, which makes it a terrific source for doing, let's say, faceted search in a search application. So we're going to leverage this as well. And someone was asking about the ability to index JSON documents, and we're going to do just that in a minute here. And what this was built with is Java, because that just happens to be the development language that I'm most familiar with. And we are leveraging just JavaScript libraries for rendering the UI. So before I get started walking you through, I did want to highlight everything I'm showing you is available in an open source GitHub repository. So if you happen to be a Java developer and would like to build and play with what I'm going to demonstrate, it's available. And we're going to have it as a link in our resources that we send to you after this demonstration. I'm also running or can run App Studio from Docker. In this case, I have it running locally, but it is available. If you have Docker Desktop, for example, and want to run the image, you'll do exactly the same kinds of things I'll be doing. And then finally, in terms of running Redis, I just like using Docker to do that as well. So I'm just running a Redis Stack instance, which Redis Stack, for those of you who haven't downloaded it before, it includes open source Redis, but then what we do is we couple with it a few modules which give you advanced capabilities like time series, like JSON documents, like search, and you get it all in the same Redis instance. So let's take those out of the way and let's get started with the demonstration. So the first thing we're going to do is we're going to select a data set to start with. And this data set ties back to the one I showed you just a moment ago in the spreadsheet, the HR employee records. So the first thing we're going to do is create an application so that we can start working with the data. And this one is initially going to be what we call a data modeling application. So what the data modeler is intended to do, it's used by my team of consultants to look at customer data that might be shared with us so we can understand the structure of it. Imagine that we're helping a customer migrate their data from a relational database up to Redis. And so there may be some transformations that we want to do so that we can operate faster on the data. So we would use the data modeler to do those types of activities. But what I want to do is take advantage of a feature it offers where we can save the data into the database and name an application. So this one's going to be the HR Redis application, and we're going to just give it a prefix. Now, when I give a prefix, it's for two purposes. One, there is an app that's literally created on the web server. And so that prefixes the app so that we can have multiple apps on the same web server. We also use it for keys in the database. So it segments the key space so that all those keys belong just to this app. The other thing I'm going to highlight, and I mentioned this in the chat earlier, is that this application is built with hashes. So what I'm doing is taking all the rows in that spreadsheet and I'm creating a hash with it. And then what I'm doing is I've created a sorted set so that I can aggregate all the data that I want my application to have access to. So it has all the key information and the ordering of the rows that I want to have on the grid. So we're going to create that application. And as it spins up, it's quickly adding those 1,000 documents that we saw in the spreadsheet. And if you look at the bottom left, you'll see that you've got the 1,000. And as I scroll through here, you can see the data being fetched quickly, right? So this is what we love about Redis, is its speed and performance. And I can take one of these rows and just double click on it, and we're just pulling the data up. Now, if you remember what Tom showed you, that operation in the background was just an hgetAll. It just pulled all the fields for the hash, and then I'm just rendering here in the UI form. So what I thought would be helpful, we're really just focusing on core Redis commands. So we're going to walk through CRUD operations, right? So we just viewed something, we're going to create a record, we're going to update a record, and then ultimately I'll delete it. And I'll show you how those operations played out in the database. So the first thing we're going to do is we're going to create a new record by duplicating an existing one, which is what I'm doing here. And we're just going to come up with a new name. And that's good enough to save an initial new record. So if you look at the bottom left, we went from 1000 to 1001. And now with this new record, I'm just going to continue working through the life cycle of change. So we're going to edit it, and let's see, we're going to change the position title. And why don't we give Bob the title of PS Consultant. And then on the office location side, let's make them a little closer to where I live, up in Boston. And we're going to save that information. Now, this is an hset command, just like you saw Tom walk you through a few minutes ago. So now we've got this updated. And to complete the whole cycle, let's just simply delete that record and take it out of the database. And that brings us, if you look at the bottom left, we're back to those original 1000. So what I want to do now is give you some insights into the commands that just executed. So if you use Redis App Studio and take it for a test drive like I'm doing here, anything you do in the application will be captured in a stream that it renders back when you go to this command grid to show you the commands and the order of those commands. So working backwards, we did that remove or delete operation. So to do that delete operation, there were two things involved with the data. The first was I needed to remove a member of the sorted set that represents my desktop grid that I showed you. So that's a zrem command. And there's the key identification information. And then I needed to delete the hash itself, which is the del command. And then if you remembered, I did the form edit, and that one was setting the position title over here, and then the office location. And so that was done with the hset command. And if you do take me up on running this application and experimenting, just double click on any of the commands and you can get to the online help so that you can understand how the commands work and some of the options that you can take advantage of as a developer. So now I'm going to, now that we've kind of done the core commands, take you back to that data modeler. We're going to use the same data set we've got loaded in memory here, but now what I'm going to do is go back and do a save as, but this time we're going to save it as a search application. So now I'm going to call this the HR search application, and we will set this up with the prefix of HRS. And you'll see here I've got UI facets as an option. So with the UI facets, I'm choosing not to show facets for this application, but I'll do one when I do an e-commerce demo here in just a moment. So if I create the app here, what we're going to do is we're going to re-add all of those HR records into Redis. You can see the 1000 at the bottom left there. But what we've also done is we've created using the ft create command that Tom just went through in the lesson, and that created a search index against all of those records. So again, you can see here, very quick for you to fetch data out of Redis. That's what we love about working with Redis. I can double click with one of the rows and you'll see the fetch there. This is an hgetAll. But why don't we actually use one of the search commands, and let's just search and match business as a term. So you can see we got lots of matches there, and we're going to just enable a highlighting feature, which is part of Redis search, rerun the query, and now you'll see the cells highlighted for the matches that we have in the grid that's visible. There's also parts of the grid that aren't, there's parts of the data that's not visible on the grid, and they've matched as well, but at least you can visibly see where we've got our matches. The other thing I wanted to show you is, in an app like this, you might want to quickly sort your data. And Redis search is really good at sorting. So in this case, I've set up my column headers so they're buttons. So if I select it, we're getting essentially a fetch against the whole data set, but we're sorting by full name ascending order by default here. When I select it again, we go with descending order. So that is a handy way to get sorting introduced to your app and letting Redis Search do all the heavy lifting for you, and obviously giving you the performance that we've come to love when we use Redis. The next thing we'll do is illustrate some of those query commands that Tom went through to see if we can create a query that isolates a subset of these records, but does so by leveraging some of those logical operators he went through. So let's say we start with salary. So I'm going to choose salary. And why don't we choose the between operator, which is really a range query. And we're going to look for an employee that has a salary between 90,000 and let's say 120,000. So we fire the search and we went from 1,000 down to 200 if you look in the bottom left. And let's just keep going. So next, why don't we look for region? So we're interested in finding employees in a certain region. And one of the ways I can do that is by using the is one of, and this effectively becomes another form of a range query. And so we're going to look for a region that is south or west. So let's fire that query. And now we're down to 113. And let's do one more. And this time we're going to choose position title. And why don't we go with starts with? Let's see if we can find starts with. There we go. And we'll do a starts with account. And fire that query. And look at that. We're down to a nice, simple 6 employees that match this criteria. And hopefully this gives you a sense of the expressiveness that you have when you want to do your searches with Redis Search. And we'll reset this. And the next thing I wanted to show you was a schema behind this. So the schema editor window is really just a rendering of the schema command, the ft create command that Tom showed you earlier when he was going through his lesson material. All I've done is just rendered it into a grid that allows me to easily change which features I want to enable in the search experience itself. So on the left, I've got all the field names, and I've got the data types, and the title I use for when I present the data so you know what it represents. Here's your field weights that Tom talked about in the next column. And then as I scroll over, you'll see that we have auto-suggest features, we have features for faceting, highlighting, stemming your text information, or enabling geo-searching. All of that's possible certainly through search, and I've made it available through this grid. Now, one of the things I wanted to highlight is if you look at full name, you'll see that we do have auto-suggestions enabled for that. So why don't we go exercise that functionality? I've got a little control here, UI control, where as I type, it will then do queries against the search index. So let's just start typing Henry, and there you go, Henry Cotton. I can select that, and boom. So it is a great way when you use auto-suggest like this to kind of steer your users towards the data that they're looking for. It's just a great accelerator for them to find information that they care about. So the next thing I'd like to do is show you behind the scenes what commands we were actually executing. So if we have a look here, you're going to find the ft search commands, and this one here was doing the auto-suggestion searching that we were doing just a moment ago. And this one here is the advanced criteria that we put together. So if you look here with the ft search, you see that we had salary number, and this is a range query. And then you have region, right, which was south or west. And then you had position title, which started with account, and we're using the wildcard operator. So that's just an example of how App Studio can help you see those commands that are executing under the hood. And if you double click on them, again, you're going to get all these details over here, and we'll provide you with all the parameters and everything else. By the way, I do see questions out there, and I promise I will get to them as soon as I'm done with my demo. So just hang in there. I'll get to those. So let me get you back to one final demonstration, and I'm going to take you all the way back to the application launcher, because now what we want to do is work with a different type of data, hierarchical data set, and that is here. And I'm going to go and I'm going to select that e-commerce product catalog, which was a collection of JSON documents. So we're going to select that, and we're going to create a product data modeler application. And I'm going to prefix that PDM, and we're going to create that. And first, it's going to take me into the data modeler. So remember the data modeler, my team uses this to analyze data that we might get from our customers. Everything is held in memory right now. It's not in Redis, but I can go from here and I can execute a save as operation, and we're going to create a search application from it. So we're going to take these JSON documents and we are going to put them into a product search application, and we'll prefix it PSA. And this time we're going to enable those UI facets because we want to create an e-commerce search experience, and faceting can be super helpful when you're in those kinds of applications. So here, what's going on behind the scenes is all those JSON documents have been added to Redis, and you can see them here. And then as I scroll down, you can see the performance, right? The JSON documents are getting fetched. And as you saw, they were pretty heavy documents. And, you know, Redis is pretty performant in getting those loads done. I can select any one of these, right? And I can double click and you can see the details of that particular product. And not only that, I can go in and we can edit it. So we're going to edit the JSON document. And you know what? I'm going to change it to the Redis Office season 6 through 9. And I'm going to save that update in JSON. And now I'm also going to illustrate a great feature of using Redis and Redis Search. And that's the ability to immediately search for something that you just changed. And that's the beauty of having a search engine combined with a database. Any changes to your source data is immediately reflected in the search index itself. So that is just a terrific way to have all that managed for you. So on the left, you'll notice we're not showing any facets, but that's just simply because we haven't told the application which ones we care about. So here's our schema editor again. And as you look, you'll see all the fields that are part of the e-commerce data set. And as I scroll over, you'll see all the features. And one that we didn't use on the last demo was facet. So we're going to enable faceting for class, subclass, and department. And I'm going to update so that now the application knows to include those in the faceting. So as I refresh the search, we now have the facets for classification, category, and department. So let's do some filtering. We're going to choose DVD software, and we'll choose sports and fitness. And there you go. That is a very quick way to get to 12 products from that catalog. So let's reset. Let's search for, let's say, iPhone, and execute that search. So we've got 175 products that match with iPhone. And you know what? I'd like to use some facets with it, and I'd like to be able to filter by color. So let me enable color as another facet. And now I'll just rerun that search. You'll see at the bottom, we did get color, but because I'm pulling so many fields over, I don't really have a lot of real estate. So I'm just going to make a quick little edit and just knock down. And this is a configuration option with FT aggregate. We're just going to knock down the number of facet field values that come back to 5. So I'm going to rerun that search. And when I do, you can see we now just have the top 5. And so now I'll filter by iPhone accessories, trending cases, and bourbon. And again, just super powerful way to find information in your product catalog by using facets like this. So I know we're running late here. I think I'm going to probably stop the demo here, but hopefully this gave you a good overview of what's possible with Redis and applications you can build on it. I'm now going to stop sharing, and why don't we open it up for any questions? And I'll also make sure I get to all the questions that might have been asked in the chat as well.
We do. There are some questions in the chat and in Q&A, Al. And I am going to go ahead and launch a poll question. We always like to meet individuals in person. So if you have an interest in attending an in-person workshop, we are running a series of in-person workshops as well as lunch and learns across the Americas and across our other global regions. So if that is of interest, please do let us know. We would welcome meeting you all in person out there, wherever you are across the globe. And Tom and Elle, thanks for those excellent presentations. I will go ahead and end this question. And then most importantly, we always welcome actually having in-person conversations and meetings with you all to answer all of your questions and make sure that we guide you on your Redis journey. So we have Redis individuals all across the globe, and we are happy to connect you to your local Redis team. If that is of interest, please do let us know. We love having conversations and ensuring that you have all of your questions answered. We'll give everyone a minute to respond. And I think actually, Tom, you responded to the last question in chat, I see. And I don't see any open questions in Q&A. I'll go ahead and end this poll question. And then I am going to launch our final poll question. We will be at AWS reInvent in Las Vegas. And I am going to actually put into the chat link. So if you are going to be out at reInvent in Las Vegas, we would welcome seeing you at our booth. We have some presentations, we'll have some other activities, and we would love to meet with you in person at reInvent as well. If you all will be heading out, we would welcome seeing you. And I did include the links. We will have our real-time in action from Hello World to Chat GPT in-person workshop series running throughout November and into January. And then we will have a Data Bites luncheon series as well running November through January. So check that out if that is of interest to you. We would welcome seeing you at those upcoming sessions. And then, as I mentioned earlier today, we do have on-demand virtual workshops that we have recorded with Al and Tom that are phenomenal to continue learning with Redis across a portfolio of different topics. So you will receive links to all of these on-demand workshops in the follow-up email with a copy of today's recording. So thank you all for your participation. We welcome any other questions that you have. And we appreciate your time today. Thank you. And thanks, Al and Tom, again for the wonderful presentation. So last call for questions. If not, everyone have a wonderful rest of your day and enjoy a fantastic week. Thank you all.